All right, guys, I'm going to walk you through. I think this is activity 232. Some of the additional calculations you had to do beyond stress. So this one calls for Modulus of Elasticity, and they give you this crazy formula. It's really not that crazy because the formula we've been using is really just elasticity is the force times the length divided by the area times the deformation. And pretty much that's what we're going to use. The only thing is it has to be done on the straight line, okay? Because elasticity only exists on this straight line area. After that, we go into plasticity, so that wouldn't work, all right? And the other thing is we're going to use 0, 0 because that's where we start as one of these points, right? So anything minus 0 is itself. So if I use P2 delta 2 as 0, 0, then really I'm just doing PL over A times delta. And I'm going to just pick an easy point. So on this line, this one looks like it's right at 400 and right in the middle here at 0.005 inches for the displacement. So I'm going to use 400 pounds times the length, and our original length, you're going to actually flip back to where we measured it, 0.4785, all right, times 0.4785 inches divided by the area, 0.00. For mine, it was 67166.563 inches. And again, we got that from calculating using our diameter, right? So use the diameter, square it, divide by 4, multiply by 5, and that's how I got my area. And times the deformation, which we just said is this amount, right? 0.005. So that's how I'll find modulus of elasticity. I'm going to just plug it in my calculator. 400 times 0.4785 divided by parentheses. I already have A stored, which is 0.0067166.563 times 0.005. And that gives me my modulus of elasticity. 5,699,264.422. And that's pounds per inch squared. And really, we should do that in significant digits, but I'm going to just leave it there. All right. So turning the page, we have modulus of resilience. Oh, this one's pretty easy. Half the stress at the yield point, strain at the yield point. Stress at the yield point, we're going to go back to find that, and strain at the yield point, we're going to go back to find. And so stress at the yield point is right here, 108,685. So 1/2 times 108,685.032 times the strain at the yield point, which I believe we found, and I might have to flip to a different packet. Yeah, we found the strain total right here, but I'm not sure if we use the yield point strain. So yield point strain is going to be the yield point right here. So about 0.095, 0.0095 inches divided by our original length for 0.4785 inches. If you're not sure where those two came from, this one, the yield point strain, and I'm calling that 0.0095, is the deformation at the yield point. And the original length, again, we flip back to the beginning, 0.4785 is the distance between. That's our original length. So there it is, 1/2 the stress at the yield point times the strain at the yield point. I'll plug that in my calculator, 0.5 times 108,685.032 times parentheses 0.0095 divided by 0.4785. And I got a Modulus of Resilience of 1078.9000527, and that's pounds per inch squared, because this one is pounds per inch squared. Obviously, inches canceled out. All right, pretty simple. Last one is a little trickier, Modulus of Toughness. So 1/3 the strain at the breaking point. Here's the breaking point. So again, just like we just did for Modulus of Resilience, the strain at the breaking point is going to be its deformation at the breaking point. So 0.005, we'll call it 3. And divided by our original length, 0.4785, times the stress at the yield point. I just used that one, 108,685.032, plus 2 times the stress at the ultimate point, plus parentheses 2 times, and the stress at the ultimate point I found right here, right? That's breaking point. At the ultimate point, it was 109,429.4501. So let's write that down. 109,429, 109,429.4501. All right. So there it is. Calculator, parentheses 1 divided by 3, close parentheses, 0.053 divided by 0.4785, close parentheses, 108,655.032, plus open parentheses, 2 times 109,429.4501, close parentheses, close them again. I actually need 2 here. Parentheses closed. And that gives me 12,092.1201. And that would be, let's see, this is in pounds per inch squared. This is in pounds per inch squared. That's inches per inch. So that would be pounds per inch squared. Because we're just adding them. We don't multiply them, right? So that's my Modulus of Toughness. Toughness. T. And that's it. That's all we had to do, guys. Yep. So you just have to do it twice because you got to do it for both aluminum and brass. If you got any questions, let me know. Thanks for watching. And hopefully I'll see you guys at the beginning of next year. Crazy, I know. All right.